Hello again, and welcome to this second part of the memory system in Agentic AI. In this part, we will be implementing real memory systems using LangGraph. We will implement short-term memory, long-term semantic memory, episodic memory, and state-aware gating with a reflection write back. In this notebook, we have everything well commented and explained, so you can easily go through it, and it's fully runnable in Google Colab. First of all, let's make sure that we are connected to our environment. This is connection, and then we need to make sure that we have the OpenAI API key enabled in this notebook to make sure that is usable. Here we are connected now, and then we'll start first of all to install the dependencies. And here, if you see, we are bringing something from LangChain and LangGraph, and then the FAISS to be used as memory stores. Here we have the things installed. The other things that the error that you see here, because I have installed other libraries into the same notebook before. And then we import the OpenAI API key and the from LangChain and LangGraph all the libraries that we need. The embedding models that we are using is from OpenAI. We are using the text embedding 3 small, and we are using the model GPT-4o mini for this example. Now we'll start by defining our semantic and episodic memory. Here we are using some documents in the semantic memory. We are defining some documents here, like kind of a stub documents, but you can use any examples that you have or any document corpus or a website that you might have to implement a real example. But here we are just to explain the concept, we are using this dummy documents here. And as we see here, we are talking about the system deployments and the failures and what happens and etc. And in the episodic documents, we are talking about that the one episode the user rejected the rolling update, and another one automation hit API rate limits, etc. And what is the lesson learned from each one? And we are talking about these documents as past experiences of the agent that we will use as episodic memory. Let's run this cell. And then to build the long-term memory vectors here, we are, as we said, we are using FAISS. And we are using from documents. We are building our and using the embedding. We have the semantic store and the episodic store, and we have the retriever to be implemented as well with top 3 results that we can get from any retrieval process. Then we will define the agent state. In our agent state, we have first of all the mode. It's either working in planning, execution, or reflection. And in the agent state, we have the mode. We have the query that is kind of the prompt, and the semantic hits from the retrieval, the episodic hits from the retrieval, and the short-term context as a dictionary, and the output with a trace to be able to enable observability and debugging. Let's run this one as well. And then we'll define the retrieval policies. So add trace here for, as we said, we define this function to append the states at every step. So we know what's going on step by step. And then retrieve semantic, as we said in the slides, we retrieve semantic memory only in planning mode. Otherwise, we don't retrieve semantic memory. And then we add to the trace what have be retrieved its own. In the episodic memory, we are retrieving episodic memory only, or candidates only in planning and reflection mode, not in execution, as you can see. So on it's okay. And then to assemble our context, we are saying, first of all, we are getting the semantic hits and episodic hits. And here to gate it again, if the state if the mode is execution, immediately we are taking semantic and episodic as empty. But otherwise, we are building our state from the mode, query, semantic, episodic, etc. And we are adding to the trace what happened. Let's run this cell. And then on the generation here, we are telling the agent what role it has. You are an agent operating in mode X. User request or situation is the query, and then select the semantic memory from the facts, etc. Selected past memory, episodic memory from the past lessons or preferences, and so on from the episodic memory. We are providing this to the agent as a prompt, and then the instructions saying that if mode is planning, produce concise plan; if it's execution, produce step-by-step actions; and if it's reflection, produce a compact lesson learned, lesson summary suitable to store in episodic memory, and output only the response for this mode. And then we invoke this prompt with the LLM, we said that we are using GPT for O-Mini, and we store the output in the state, and we trace it. And finally, to implement the reflection write back, if the mode is a reflection, we store in the episodic memory the output episodic and in the episodic memory and with the reflection update to make sure that we have the summary here. And we return the tracing the what happened. And here we build our LangGraph pipeline. Actually, here is just like a sequential graph. We have the semantic, episodic, a sample, generate, and write back. And the edges, they start from semantic as an entry point. And we edge from semantic to episodic, then to assemble to generate to write back, and write back to end. So it's just a sequential graph, and we compile. Then let's run now and see what will happen. So we are running in the run. Actually, we're building agent state, and we invoke the app that we compiled here, the graph, and we show the results in a formatted way. So in the first run, we are in a planning mode, deploy service with minimal downtime, suggest a robust strategy. And then the second run is execution, execute the deployment now. And the third one is a reflection, saying to the agent that deployment failed due to API rate limit during cutover, summarize lessons. And then the fourth one is plan the next step after deployment, avoiding the last failure. Remember this one. Let's run this cell and see what results we get out of it. Okay, here we go. In the planning, here we see the planning mode, the query that we had, and the selected semantic memory. We had two candidates, and then selected episodic memory, two candidates that they are relevant to this very specific query. And here we have the output, we have the plan, objective, constraints, rational, the detailed steps. And in the trace, we see, first of all, it retrieves semantic, from semantic memory 3, but the count, we got 2 only that were used. From episodic memory as well, we got 3 because the mode is planning, and then we used only 2 semantic and only 2 episodic in our context. And then we generated output as like almost 2000 charts, and we write back added false because the mode is not reflection, and we don't write back unless the mode is reflection. In the execution, we see the same structure, and then we see here important that semantic selected and episodic selected, they are null. We don't have any, they are empty. We didn't select any long-term memory. And we have the output. Here are the steps that were taken to execute the plan. And then we see in the trace, semantic count 0, episodic count 0. And in the context, we confirm that we use 0 of them, and then added as well write back false because we are in execution mode, we are not in reflection mode. The third step is the reflection mode. Here as well, semantic memory is not used, but episodic memory is used, and we can see that in the trace. Again, we have 3 candidates, but we used only 2, and we write back true to the episodic memory as a lesson learned from this experience. The last step here, as we see, planning, and we have semantic 2 in the episodic 1, because we told the agent that we are talking about only the last failure. So it knew that it will use only one experience actually from the episodic memory. That's why we used, or we retrieved only one candidate here. And then here are the second plan with output here, as we say, deployment plan, the steps, and the constraints, the rationale, etc. So, and we see in the trace that we retrieved actually in the episodic semantic retrieve, we retrieved 3 but we used 2 in this, and we added false because it's not actually a reflection mode, because it's a planning mode again. And here finally, to finish with, to make sure that the lesson that we have stored is really stored in the episodic memory, we are just doing a retriever invoke here from the episodic memory and see what is written there. Let's see what we have there. So the last lesson that we have stored in the episodic memory actually is automation hit API rate limits, the lesson add exceptional back off, and batching. And actually, this is exactly what we have written in the reflection step. If we go up to this is the reflection step, and we see here the lesson deployment failure due to API rate limit. This is the lesson learned. This is a summary of the lesson, which is exactly what we had here: an implementation exceptional back off, and then when API, etc. These are the summary of the lesson that we had, etc., etc. So this confirms that our past experience has been written actually to the episodic memory, and it affected actually the planning of the next step, which confirms that the behavior has changed over time or across time with the past experiences that we retrieved from the episode, stored and retrieved from the episodic memory.